My dear students, now we will see how exactly the stack can be implemented by using dynamic memory allocation. So, in the previous class we have seen the stack implementation using array. Not much of difference. Only difference is when you are trying to use array as a storage unit for the purpose of stack, size of the memory is limited. Whereas, in case of dynamic memory allocation, the size is not limited. It means this stack can be used for any amount of data. There is no limitation on the size of data that you are trying to store it inside this. So, that is only the difference. But which is better? If you know the size of the data which comes into your operations, it is better we go with a array representation. If you are not really sure about the amount of data which falls into the stack, then you need to go for dynamic memory allocation. Obviously, dynamic memory allocation, when you write the program, it is slightly complex, whereas array representation we have seen in the previous class, it is quite easy and relatively easy, whereas dynamic memory allocation is slightly complex compared to the previous program that we have written. So, therefore, the organization, the way in which you do the operation is same almost, but only thing is the space that you are trying to use is dynamically being taken from the memory manager and you will be using it, and you are not fixing the size of the array, size of the stack. So, that is only the difference. Okay. In fact, if you really look at the program that is already written on the board for the sake of easiness, it is very similar to the previous program. You can compare. At the end of this video session, I will be running the program and demonstrating the same program being run in the machine. In that case, you will be seeing the program now written on the board today, and what we had written in the last class. They are very similar, not much of difference. Okay. Now, let us begin. See, you need to, as I told you in the last class itself, whenever you write a program or whenever you start developing a program for a algorithm or a software for any kind of problems, first of all you have to prepare yourself what all you require. You require some storage space, you require one stack pointer, you require some operations, menu operations. 3 operations you are basically doing it. One is called as a push operation, it is insertion of data into the stack. Second operation is called pop operation, you are deleting element from the stack. And the third operation you are doing is called display, display the content of the stack. So, these 3 operations you are doing it, otherwise you are exiting it. So, in that guidelines only the program have been written. Okay. Now, let us see how this program goes. So, as usual there will be stdio.h, something like this. Now, if you look at this, dynamic memory allocation, I am now creating a node, whereas in case of previous class you would have seen I had declared an array here, something like this, array like this. This array is fully defined for you, it is available for you once you use it as an array. In the last class I used the stack underscore array. So, that is the name of the array that I had declared. But when you declare it, actually the whole thing is available for you. But whereas in case of dynamic memory allocation, you will not be having a predefined data storage for you. You need to ask memory manager the space that you look for. So, therefore, to store one data, to store one number or one whatever data which comes into the stack, first of all I am now creating a small a node kind of structure. You would have seen this in your last semester class. A structure is basically holding some heterogeneous kind of elements. So, therefore, what I do is I am trying to store this one as one node, second one as node, third one as node, fourth one as node, fifth one. Keep on adding the nodes, something like this. Now try to imagine, now each time the node is being asked and you will be creating that node, and that node will be filled up with the data. And whenever you are doing deletion, you are removing a node. Whenever you are inserting, you are creating a new node, something like that. Okay. So therefore, first of all, I am now writing one structure called as a node. Here you need to understand this little carefully. In this structure called as node, I am now using one variable called as a information, which is basically storing the data. So there also we had declared it integer stack underscore array of size 6 or 5. So it can store so many n number of elements. Here data type I am using it's an integer type. So therefore integer information will be stored, right. In the last class, if you recall the class in which I stored here an array, here 19, 23, 46, something like this, I had stored numbers. So these numbers are nothing but integers. So therefore I am trying to take integer data. All right. Okay. So preparation that you are supposed to do before you get into the program is this. First of all, try to create a node. This node, this is slightly cryptic, but as you proceed, you will understand this better. So first of all, I am now creating a structure node. Name of the structure is called as node. There are two components. What are these? The first component is called information. Second one is called a pointer. Second one is called as a pointer. This pointer is capable of pointing to a structure. So this is what you are supposed to understand when you write this structure. Let me spend little time on this. Your teacher would have told in the previous semester classes that a pointer is basically a variable which now pointing to a specific data type that you look for. All right. Now, why I am using this pointer over here? Because once you create a node, I am creating one node. This is the first node. This node should sit just below this. It means to keep this data below this, I need to know the address of this. So therefore, first I create a node, it will have an address and it will hold the address of the next node. It will hold the address of the next node. So it will hold the address of the next node. So therefore these are all connected, right? But this problem was not there when we used the array. The reason is when you declare a variable called as an array, obviously 0 element, the next element, third element, fourth element, they are in an adjacent manner. You need not have to worry. A stack of array 0 is the first element, stack of array first, the second element, stack of array 2, that is the third element. So like this, they are stored successively, they are stored physically successively. Whereas in this case, it is not necessarily that it is stored successively like that. You are trying to create one data. So that is the speciality of computer science, wherein which you start imagining that now data are stored appearing sitting one below the other, but they are not physically adjacent. They are farther away, but I am storing the address of this with this particular thing. So therefore they are connected. I am assuming that this is sitting just below this. This is set just sitting below this. It is as good as just like your register number in the VTU. So you have here 4MH 19 CS 001, 4MH 19 CS 002. With respect to this data, they are adjacent. But are you sitting adjacent in the classroom? No, you may not sit. But logically you are adjacent. With respect to attendance register, you are adjacent. With respect to VTU, you are adjacent. Whereas physically you are not sitting adjacent. You may be sitting anywhere else, but I am calling this is 001, this is 002, this is 003, that is 004, something like that. But they are logically adjacent. So therefore, you need to create a structure such a way that they are connected. once you create one node, this node, now I should create a facility for storing the address of the next node, address of the third node. So therefore they are connected. Of course, you will be using the similar kind of structure even in the linked list. Anyway, in the beginning it is very little difficult for you to understand, but please go ahead with this. When you understand linked list, you will understand this better. Okay. So therefore, structure node star link. So this is what you are supposed to understand. Now I am creating one link. Link is a variable which is of type pointer. To what type it points? It is now pointing to a structure node. You know that in your previous class your teacher would have told integer star p. Integer star p. What does it mean? It means p is a pointer capable of pointing to an integer. When I call character star p, what does it mean? P is a pointer which is capable of pointing to a character, like that. So link is a pointer capable of pointing to a node. It means one node can connect to another node through this address, because a node means there are two components. One data component, second one address component. This data component will give you the real number of the particular value of the node, whereas this link component gives a connection to the next node. So therefore I am using these two components in the node. So therefore when you call it a node, there are two components. What? Data component and its link component. Very similar to even in your array also it is there. Okay, take this case. In this array I am storing 19. This is 23, 0, 1, 2, 3, 4. What all you have? You have here one data component, second one, this is the address component. Where exactly this is stored? This is stored at 0th location. Similarly, data component and address component. Data component, but address, it is clearly understood. It is an implicit representation, whereas here explicitly you have to define this. That is only the difference. So you have a data component and the address component. Address component in case of array is an intrinsic, it is an implicit, you need not have to mention it, whereas here you have to mention. That is only the difference. So therefore when you call a node, we will have two component, data component and an address component. So therefore link is a pointer capable of pointing to a node. This is a recursive definition. Definition itself is a recursive. So I am now declaring a new variable called as a top, just like your stack top. Basically initially will be null because no nodes are there. So therefore I am now pointing this top, which is basically a null. So stack top. So in the previous class I declared a variable called integer stack top. So like that, now I am having a top which is basically a pointer. Initially this will be null. So there we had declared it as integer stack top equals to -1. Like that, here stack top, now it is not pointing to any node in the beginning. So therefore this is, if you understand this particular definition, then rest of the program will be very easy for you, and it is very similar. It is very similar. All right. Okay. So assume that this is known to you, my dear students. If you don't get, if you are not understanding this properly, you can just come to my chamber. I'll explain to you how exactly this has been defined. Anyway, the program is also been shown to you, and you can just discuss with me, either with me directly, or you can just interact with the online mechanism. Okay. So assume that this has been defined by you. Now it is now looking like this. How does this look like? This looks like this. Okay. Now I have a pointer called as TMP. TMP is a pointer which is basically a pointer, and initially which is now holding null. TMP is a pointer initially holding null. It means it is not connecting to anything. Ultimately, as and when you add a node, this will hold the address of this, that's all. The new node address will be stored here. So like this it goes on. So dynamically this will be stored, and similarly what is being pointed by this top, that will be deleted. So therefore this is top. Top is a pointer which is basically holding null. So this is what we have seen. Okay. Now we will go to this main, as like the similar previous program, not much of change. So I am just taking an integer choice, then while unconditional, alright. So printf, so 4 options for you: push, pop, display and quit or exit. So printf, enter your choice. So read that, then you will be, now in the previous case I used if statement, now I am showing it you with another way by means of this switch. So based on the value of the choice, so you will be switching to one of the operations. So either you will be going to the push or to the pop or to the display, or you will be exiting it depending on what is being typed, whether that's user has typed 1 or 2 or 3 or 4. If he presses 1, it goes to insert. If he presses 2, it goes to delete. If he presses 3, it goes to display. If he presses 4, then you will be coming out of the program. So this is what you are done. This is very similar to the previous program. All right. Okay. Now we will see how does this push operation starts. So let us begin with initial state. In the initial state, we have here top, which is basically now holding null. Nothing is there in this. This is nothing but null. All right. Okay. So what I do, so it is the same procedure. The same procedure there how we did here also, we just do it. What is that? So first of all, see there in case of stack representation by using array, first thing that we do is actually check for overflow. If overflow is not there, then you can do the insertion. Here overflow is not there. There is no limit on size of the data that you are storing in stack. So therefore you need not have to check for overflow. So that step is gone. Now you are left out with only 2 steps. What? Create a new node. Create a new node. Then in that node insert the value. Change the value of the top. That's it. Keep doing this. Keep doing this. Okay. Now we will see. So first thing, no need of checking overflow. So now I am now creating a local variable called as a TMP. TMP is a local variable. See here. TMP is a local variable. It is basically a pointer. Next I am declaring one local integer called as push item. TMP is equal to structure node pointer. So this should be known to you. So since you are familiar, first time you are using this syntax, you need to understand what exactly this. So therefore this line of code, structure node pointer, it means you are returning a pointer. Why? Because TMP is a pointer. I have declared TMP as a pointer. So therefore what you need to store in a pointer, what something another pointer only should be stored. So therefore you are returning a pointer. You are returning a pointer and you are storing this in TMP, which is defined as a pointer. Okay. Now you are allocating a space. Now you are asking memory manager, please give me a space. That is the malloc function. You have seen in your previous semester class. Malloc size of structure node. Structure node. Now you create one node, empty node, and give me that space. That address you are now returning here. You are now returning that address, and that address will be used here as the address of the node. Okay. And that will be stored in a TMP. So therefore assume that one node will be created. This is the node that has been created. Please observe this carefully. And this address is now stored in TMP, because I am now doing TMP is equal to structure node malloc size of structure node. How much size? Size of this node must be size of this structure. How many bytes? This is 2 bytes. This is 2 bytes. Totally 4 bytes. 2 bytes for the integer, 2 bytes for the pointer. So totally 4 bytes. 4 bytes will be allocated. and that address will be returned to you. That address will be returned to you. So, it is as good as, now you come to the classroom, you ask teacher, sir, where I should sit. Teacher will sit, go to 4th row and second seat in the 4th row. Now, he has given the address where you are supposed to sit. Now, 4th 4th row, and in that the second place is yours, something like that. In this memory big space, you have been given a space. How much space? You have been given the 4-byte space, because you asked for 4-byte space. You asked for 4-byte space, so therefore 4-byte space is allocated to you. That 4-byte address where exactly this is sitting, right? So, when you make a big layout by the corporations, and every site will have address. When you apply for some site applications, so they will allocate one space for you. One site is allocated. The site will have address. That address is given to you. So, you will be given with the 4th main, 3rd cross, 4th street, 10th house is allotted to you. So, that is address. When you ask for some space, that space will be allocated to you. Like this, temp equal to malloc, please allocate memory allocation. Malloc means memory allocation. Memory allocation, size of structure node. Size of structure node is 4 bytes. So, please allocate 4 bytes for me, and please return the address and store this in TMP. That is the syntax what is being written here. Okay, TMP is equal to structure node malloc size of structure node. Okay. So, then node has been created and its address is there here. Please observe this now carefully. Now, top is having null, TMP is having the node, empty node, and its address is stored in TMP. So, this is the status right now. So, printf enter the new value. So, please enter the new value to be stored into the stack. So, into the stack. So, therefore, it has got 2 components. One is the data component, you have already seen here. So, please enter the new value, read that value. TMP arrow information, it means it has got 2 components, TMP arrow, TMP pointer. You can see from this, TMP information, TMP link. So, these are the 2 things which are there visible to you in this. There are 2 components in this node. Okay, so, TMP arrow information is equal to pushed information. So, therefore, the first number called as 19 is stored there. So, pushed item is stored into TMP arrow information. Next, top equals TMP arrow link. What is that? What is there in top? Top right now is having null. So, that is now assigned to TMP arrow link. TMP arrow link. So, what is there here? Null. So, therefore, null will come here. Null will come here. What is there in top? Right now null. So, that will be stored into TMP arrow link. Alright. Now, that is stored here. Next, top equal to TMP. Now, what is there here? Address of this node, that is copied to here. So, therefore, earlier it was there null. Now, this is holding the address of this. This is holding the address of this. Earlier, till now, top was holding null address. Now, top is holding the address of the newly created node, and newly created node, its link is now holding the address called null. So, this is how it is there. I think next time when you do the insertion, you will understand much easier. Okay. So, you will be coming out here, this is the push end. So, after that you are coming back to this while loop, while printf, you will be asking the user to 1 or 2 or 3 or 4. Okay. So, 1 is pressed, assume that 1 is pressed, you are coming here, you are going to this push operation, you will be coming here. So, I am now declaring a new variable called as a TMP, is a pointer capable of pointing to a node. Then pushed item, TMP is equal to structure node. So, now I am creating a new node, right. I am now taking TMP. Now, a new memory is allocated, memory space of 4 bytes, and its address is now stored in TMP. That is what this TMP is equal to this. So printf enter the new value, scan that value. TMP arrow information, it means this has got two components. TMP arrow information is equal to 25. So you are inserting the 25. Next, TMP arrow link. TMP arrow link. Now, which is now holding the address of what is there in top. What is there in top? Top is holding the address of this node. So therefore, now this is copied to this. It means this address instead of this null, now this is now being stored. And top equal to TMP. So therefore, this will become top now. You understood now? Top will be holding the address of the newly created node, and this is now pointed by this, like this. TMP, sorry, now this top holding the address of the newly created node, and this newly created node, its link is holding the address of the previously created node, and here I have not changed it. So this is null only, like this. This is null only. It goes on. Now when next time when you create a new node, so top will be holding this. So therefore, take this TMP. TMP will be holding the address of the newly created node. Next, like this. This I am storing the data. This is 93, some number. Then this will be holding the address of the previous node. Where is that previous node address? Previous node address is there at the top. So therefore, this is copied to this. That's what I am doing. Top is copied to TMP arrow link here. Now it is holding the address of this. And this will be called as top, because TMP is copied to top. So therefore, top is holding this. So like this I am doing this. It means in this example I have created 3 nodes, 1, 2, 3, and top will be holding the address of the node which just came last, which the element which came last, that is available here. So therefore, that can be deleted very easily. All right. Okay. Now the sequence in which the elements came to the stack, they are stored, and the element which came last, that address is there at the top. The node which has come last, in that data is there and there is an address component. Data is there and address component is there. That address holds the previous data, previous node. In the previous node also there are 2 components, one data component and its previous address. So that is also having 2 components, one its data and its previous, but here it is null. So therefore, no more previous data. Like this you have to understand. Okay. So I am removing the elements from the stack till I get the null. This is how I am doing it. So inserting the this end and deleting from this end only till I get the null. So this is what the stack operation I am doing it. All right. Okay. Now we will see with the pop. So pop is very easy, but in the previous class also, when we do the deletion of elements from the stack with the array representation, so what we did is actually first thing is you check for underflow. If underflow is there, you cannot delete any elements. Here also underflow should be checked first. Overflow is not there, but underflow will be there. If there are no elements, you cannot do the deletion operation. So therefore, first thing that you are doing is delete, first of all check for underflow. How to check? So structure, you create one local variable called TMP, which is a pointer capable of pointing to node like this. If top equals to null, it means no nodes are there. So that in the previous class we have seen, if stack top equals to -1, it means no nodes are there and no elements are there. Here I can say if top equals to null, stack is empty. Else means stack is having some data. How do you get it? Because top is not equals to null. Top not equals to null means you are doing this. You know it better now. In this case there are 3 elements. How to do that? Just to remove this and make top is holding this address, that is it. Just make this top, now we are holding the address of this, that is sufficient. That is deletion. Deletion of a node is simple, changing this. Right now it is holding the address of this, instead of this, now let the top hold this address and disconnect this. That is it. Top equal to TMP. I am now passing the top value, I mean its node address, into another variable called TMP, just for the sake of freeing, So printf the pop type. So which one you are removing out of these three? So you are removing this. So therefore I am printing the value of this. So before you delete, you do the display. So therefore I am displaying this 93. You see, observe this carefully. Top arrow link is now copied to top, right? So this is top arrow link is copied to top. That's it. Then free this temp. I mean that's why I copied it to this. Otherwise I would have simply done it. So top arrow link is copied onto this top. So that's a simple deletion. Similarly, display also, first of all, to do display, what is that operation you are doing is, first of all you check for underflow. If there are no elements, you can't display. If some elements are there, top is not equals to null. So there we have checked stack top is not equals to -1. Here it is checking with a null. So same procedure. So create one local variable like this. If top equals to null, it means stack is empty. Otherwise, so print the elements while ptr is not equals to null. So ptr arrow information is printed, go to the next node, ptr equal to ptr arrow link. So then keep doing this. So till where? Till you get link. So node equals to null. When node equals to null, you can't really go further. So therefore just stop the program. So this is how insertion, deletion and display program will be there. Now I will be demonstrating this at the end of this video with a program being written in my computer, and I will run how to do this actually. You should carefully observe these three very important things. One is creating the node. First of all, defining the node in this way, that is very important. Malloc function is very important. Allocating the memory and using of these pointers. That is why I told you in the beginning, this is biggest advantage of dynamic memory allocation is actually no limit on the size, whereas the disadvantage is the program is slightly complex compared to the previous case. Okay. So I have explained to you two methods of implementation of stack. Now in today's class we will see one or two cases of one or two examples where exactly the stack will be used other than what is there in the syllabus. So in the next class I will be explaining some of the applications of stack, but which are there in the syllabus. Now today we will see with two examples which are not there as a part of the syllabus, but let us see where exactly this stack will be used. Right? You would have seen there is a concept called palindrome, right? There is a concept called palindrome. The characters which are there from the left to right and right to left, they are same. So this is how the words will be used. Some of the words will be used something like this: MADAM. Either you read from this way or this way, it looks the same. So if some inputs are being given to you, it could be number or something like this, say 1, 2, 3, 3, 2, 1. So it is basically a palindrome number. Whether the number or the text which is given to you is of the form palindrome or not can be checked by using the stack. You have seen this by using string operations in the previous semester. This can also be done by using stack also. How? Okay, so what is that you are supposed to do is actually take the input string. This is your input string, right? You take one stack, right? So in this stack, go to the middle of this input data. So there are two cases that you get. One, the data could be odd number sized or even number sized. You need not have to worry. If you are getting a even numbered as a size of the data, then nothing to worry. So, right, take this off and take that off, and you can just do it. If you are getting a odd numbered sized data, say for example 9, in this example madam, basically it is a 5-character palindrome. Here the size is 5, so therefore what you are doing is divide this and just leave out the middle one. Leave out the middle one. So in the, if it's odd numbered, go to the center, just what is there at the center, you just leave it out. Whereas in case of even number, nothing to worry. So divide this into half, right? Try to store this into the stack. First of all, from the left side you are doing this. So go to the first element, store it here. Go to the second element, store it here. Go to the third element, store it here. Once you reach the half, in odd numbered or in the even number, whichever, I have already told you how to operate this. If it is a even number, nothing to worry. If it is an odd number, just remove that, don't consider the middle one. Okay, something like this here. So therefore now you are stored, okay, let us consider some number like this, 1, 2, 3, 3, 2, 1. I would like to check whether this is a palindrome or not. So first to divide this into two parts. So starting from left to right, go store this here 1. Next store this number 2 and store this is 3. These are the three things which are there in the stack. So once you reach half, take this number and compare whether they are same or not. Then if it is yes, still you have to check little more to conclude it's a palindrome. But if it is broken there itself, then palindrome will not be valid at all. So therefore you have to go till the end if the previous steps are matching. All right. Okay. So 3 is matching. Okay. Next is go to the next element this side. Then take out one element from you do the pop element. So 3 has gone. Now 2. Right. Then it's okay. Then take out 1 and take out 1 from this. If they are matching till you reach the end of the input elements, then if you succeed at every stage, then you will be called as palindrome. Don't succeed, there itself you have to come out. So this is one of the examples, at the early examples that you can just use it for the understanding the stack. Let us look at another slightly little more complex problem of using the stack. You would have seen in your programming languages and all, when you write syntax with certain mistakes, especially when you write the equations and all, it will immediately, the compiler will tell you there is a error in this. How exactly this has been identified? Let us take the case of only with the input equations, right, expressions. In case of expressions, you would have seen sometimes you will be using the open brackets and sometimes you will be using the closed brackets. And when by chance if 4 number of open brackets are there and 3 number of closed brackets are there, your compiler will tell there is a problem in this syntax because one bracket is not closed fully. So you would have seen at the compilation at the bottom of the compiler will show you that actually there is one mismatch in the bracket. How does that computer understand that? So they have written a program inside the compiler by using a stack to implement this. Okay, take this case. So 1 plus x square plus 2 by chance if you have written one expression something like this, 1 plus, I am just taking some arbitrary examples, 1 plus x square plus 2 followed by open bracket 4x plus 3 and close the bracket and put on semicolon, So it will indicate saying that actually you have done one small mistake by not putting one bracket. How does the compiler will understand this? It will not understand by itself, like human being. You means actually the fellow who has written the compiler would have written a small program by using a stack just to give an indication for the user. How does this works? Okay, each time when you get open bracket, put this into the stack. Put this into the stack each time. Whenever you get one close bracket, you take out one bracket from the stack. After reaching end of the expression, if there are something which are left out, then it is called as an error. Okay, now let us see in this case. So I have written once I am getting this, so I am pushing this. So 2 times I am getting this, I am pushing this here. So after some times I get one close bracket, so I take out one open bracket out of this. But I have reached the end of the expression. Once you reach end of the expression and still there are something left out here, it says there is an error. So this is how it understands. Say for example, if there is one close bracket like this, so even when you go for this, whenever you encounter close bracket, take out one element from the stack. So therefore this will also go off. After reaching end of the statement, end of the expression, you will have nothing in the stack. So therefore expression at least from the syntax wise it is perfect. At least from the brackets wise it is matching. All right. So but this is not as simple that we think. So there may be some kind of multiple kind of brackets which are there. Sometimes we will be opening a flower bracket, sometimes we will be opening a square bracket, sometimes we will be opening angular bracket, something like this, actually curved brackets. So there are many kinds of brackets that you will be using it. How does these things will be checked? So whenever you can push any kind of open brackets into the stack. It could be open bracket or a square bracket, flower bracket, whatever it is. You put an element into the stack, and each time at the end of the syntax, when you just continuing from left to right, whenever you get a close bracket, you take out one element from the stack and ensure that they are matching, right? When you get a flower bracket, on the top you also should have a flower bracket open flower bracket, and here it is a close bracket, and this can be taken out. And keep doing this. By chance if there are any kind of mistakes which is there, now here the closing bracket is a square bracket and the open bracket is a flower bracket which is coming from the stack, then there will be a mismatch. So there also there will be error will be declared, and the compiler will just give the indication. So today I have just given 3 examples, one with a palindrome representation, how to check a palindrome, and how exactly this brackets can be used with the 2 kinds of cases, only one type of brackets, and multiple kinds of brackets which are there. And of course you will be seeing it in the next class, how these stacks can be used for specific operations which in everyday programming language operations you will be using those. So one is called expression evaluation, and convert expression into postfix operations. So these 2 are associated, they are 2 independent operations, converting expression into postfix and evaluating the expressions. In these 2 operations you will be using stack exclusively. There are many other applications, but what is there in the syllabus are these 2. We will see those things in the next classes. This written on the board is now shown here. With the same variable being used, 4 kind of options: push, pop, display, quit, and 3 basic functions like display function, then we have a pop function and push function. So we will run this program now and look for all possible cases. Now we can see on the screen 4 options are there: push, pop, display, quit. When we run this program, we will not get any kind of overflow. The reason is stack implemented by using dynamic memory allocation will not have any kind of overflow. Whereas in case of array implementation, we have seen in the earlier case, since the size of the array is limited, when you add more number of elements, than the size of the array, then it says overflow. Obviously, in case of implementation of this kind of program with dynamic memory allocation, there will be no overflow, only underflow will be there. So therefore, we will check only for underflow, and we will try to look for all possible cases. So first we will insert one element. So 10 we will insert. So 10 is inserted. I will insert one more element called 20. Now there are two elements. We will add one more. Now we have 30 into this stack. We can see from the content of the stack, 10, 20, 30. 30 is there on the top of the stack. So you can keep adding any number of elements into the stack. So you can see the content now, it is 10, 20, 30, 40. 40 is there on the top. So if I remove one element, that means popping an element from the stack. So 40 will be removed out of the stack. So I'll press 2, you can see popped item is 40. It means there are 3 elements left out in the stack with 30 at the top. You can see from this 10, 20, 30. So you can keep removing the elements from the stack and check for underflow. So how to check? So press 2, so 30 is removed. Now I will press 2 again, that is removing of an element from the stack. So 20 will be removed. Now I will do deletion of one more time, so 10 will be removed. Now if I try to remove any more elements from the stack, since no elements are there in the stack, it says it is empty, stack is empty. So now we have checked with the insertion, deletion, underflow, and also we have simultaneously we have seen display of elements. So after checking all the possibilities, I can do quitting this program by pressing 4.